Let me show you again another example, that is the incompressible tube setting in the system folder. So let me copy here. So I can just go to the test case, and we can run cp-r from tutorial simple form and tube setting. Okay, so that test case we want to copy into our present directory. Can go to the tube setting from here also. So this is the test case that we want to see, and if we see the system folder, we can see here that there is a folder name as a topoSetDict. Okay, now let me show you that what is the written in the topoSetDict folder. Okay, so here you can see here that we are selecting some cells from the given box. So this is converting box to cell. So all the cells that is within this box, it is going to be selected. Okay, so this is first time we are selecting these cells. That is why we are using action equal to new, and the name of this cell set will be actuation disk1 cell set. Again we are creating this complete set into the set to cell zone. Okay, so we are defining a cell zone from this set. Okay, so this set we have created here, and we are defining it as a cell zone. This will be complete as a different cell zone, and the name of this cell zone will be actuation disk1, and that is why the source is equal to set to cell zone, and this cell zone we are defining first time. That is why the action is written here new, and the source will be whatever the cell set we have selected here, that will be written here. Again if we go new, then we have created another box to cell, and then we are again defining set to cell zone, and we are naming it as an actuation disk 2. Okay, now let's see how this will act as a into the polymesh structure. So let me show you. So first I will run block mesh. So block mesh has been run. If I open the paraform, so this is the complete block mesh structure is given here. Okay, so this is the complete cell. So you can see here that if I show you, this is the data level you can read here. Okay, so if I open the topoSetDict of this test case, so you can see here that this is the range. Okay, so here this x-axis will go from this point to this one. So this is minimum x to the maximum x, this is the minimum y to maximum y, and this is the minimum z to maximum z. Okay, so I think this, if I open the x-axis, so 58100 to 5810015. so I think this small strip will be created in x direction. Similarly, I think there will be some cells in the y direction based on this min y and min max y, and similarly there will be one strip in the z direction. So there will be one cuboid type of cells has been selected within given this box, and this will be converted into the cell zone. Similarly here it will be happened. Okay, so you can see here that there you can find that the cell set has been selected 0 cells. Okay, because before that we have to run the snappy hex mesh command. Okay, so here in constant folder you will find that this stl should be added, and then after that we can run the topoSetDict command. Okay, so let me show you what this stl file is doing here folder. Okay, so if I open the mesh here after doing the snappy hex, so this is the mesh, and this is the stl file. Okay, So let me just off this background mesh. Okay, so this STL file will be created on this background mesh, and this kind of structure is being formed after doing the snappy Dict. Okay, so we have already run the snappy Dict, and here you can see that there are two extra folders, that is 1 and 2. So if you run only snappy dict command, then it is going to create 1 and 2, and it will not modify this polymesh folder on the constant folder. Anyway, we will discuss these things. So here I can go to the last folder of this tube sitting form, and here you can see that this kind of STL has been imaged on this background mesh. Okay, so these things you can see here. And now let's run the topoSetDict, and let me show you that what different kind of this topoSet is going to select, what kind of this cellZone set. Okay, so if I using topoSetDict from the system folder, then only you have to run this command here. And here you can see here that now it is selecting some cells, so it will select cells in this box, and then it will create one cellZone set. It will also do the same here. So if I open, okay, it has been updated in this folder 2. So here you can go, and here you can see that this number of cells has been selected as a cell set, and one zone has been created with the name of the actuation disk 1 and actuation disk 2. So this is the cell set, and from using this cell set, one zone has been created here and one zone has been created here. Okay, let me show you this paraform again. So if I open this and let me just on the set and zones. Okay, so let me include both things, and if I show you, let me just turn off other cells. We are not going to see other cells. So I am just running the cell set and cellZone set. Okay, so there is no cell set in the 0 folder. We have to go to the second folder. Then we can see. Okay, so here you can see that number of cells related to this cellZone sets. Okay, let me just go to the one kind of cells. Okay, so you can see that this number of cells here, this is the actuation disk 1, and another actuation disk 1, 2, you can see here. Okay, so this is going to act as a kind of a rotatory motion kind of things, can be given into given cellZone set. Okay, now if I open constant folder, okay, you can see that there is a one every option. So you can see that the rotatory information is given on this cellZone sets. Okay, so actuation disk source we have created here, and here actuation disk source we are creating here. So here we are selecting the cell set equal to actuation disk 1, and here you can see that we are selecting the cell set that is actuation disk 2. So this kind of simulation you can do using the topoSetDict. This is another example, and remember that we are not going to the simulation part, but you can just go to the you can just use this all run command. So we can take any kind of a test case. I think multi-region heater will be more better because it contains all kind of topoSetDict command. So now if I go to the our topoSetDict, so here it is the find here, and here you can see that this is the topoSetDict. So you can see that different kind of command is written here. And so friends, this is our tutorial, and here also you can see that this is the blockMeshDict and this is the topoSetDict. Okay, and this is the case with the multi-region. Okay, multi-region means where there are two kind of region that is acting each other through a interface. Okay, so there will be one left solid, right solid, there will be one heater and one layer of the water flowing uh, through the interface of the heater, and there will be one top air. Okay, so such kind of region where two different kind of the region, like here you can see this, these three are something that is solid and this is the fluid, and this we can also treat as a fluid. In such situation we called it as a multi-region. Okay, so that is something that I will explain in other tutorial, that how this multi-region solver works. Here we are going to explore about the topoSetDict, and I think this is the example where many type of topoSet many type of the operation has been performed using this topoSetDict. So here you can see that this example, this is used to create the headers. Okay, so for example this has been created a new cell set, okay, using this box. Okay, again some more number of cell set has been added into this cell set. Okay, so first time when this cell set has been created, then this action new has been required, and when you are adding some more cells to this header cell set, then this action add is required here. Okay, now once you created this cell set, you are converting this cell set into the cell zone. Okay, now here why, what is the difference between the cell set and cell zone? There is a minor difference. Okay, you can also use cells if you are doing some FV operation, or if you are doing the boundary condition treatment, then you can either use the cell set or you can use the cell zone. Okay, both is going to work here. Okay, but in the case of the multi-region problem, when you open this things, so you can see that we have to separate the different cell zones, then this cell zone is required here, then you cannot use the cell set concept here. Okay, what I mean to say that give wait for a little bit, then I will explain you. Okay, but the concept of the cell is set for boundary condition treatment and for every upstream treatment or such kind of treatment, whatever you are doing from the user defined perspective, this both things are all one, in a way both things are the same. Concept of the cell zone and cell set are the same, but sometimes cell zone is preferred over the cell set. For example, if you want to create different region, different multi-region, then this command can only separate the different cell zones. Okay, then it is required to convert this cell set into the cell zone set. Okay, so this is the, this is where we create a cell zone set of the heater. Similarly, we are creating left solid void, and these two command will create a first cell set and then it will create a cell zone set. Similarly, it will create a right solid and it will create a top air. Okay. So these things has been created for heater, left solid, right solid and top air. Now other than this, whatever the this cell zones of the top air, right solid and left solid and heater we have created, apart from this zones, whatever is left, it is called as the bottom wall. bottom water, sorry, it is called the bottom water. What the what in this topoSet has been done, first it has been selected all the cells that is belong to the header cell set, left solid cell set, right solid cell set, top air cell set. So this will select all the cell sets that has been predefined over the top of this topoSet dictionary. This this all the cell set up to here has been selected here till here, and then one action has been performed that it will invert all the cell set. Okay, so whatever the cell set you have selected here into the bottom water cell set, it has been inverted into the bottom water cell set. So whatever you have selected earlier, this convert command will automatically rechange it. Okay, so it is going to select those cell set which has been not selected here. Okay, so this has been performed here. So whatever the cell set has been not selected till here, it is going to be selected, and whatever it is going to be selected, and other cells that has been selected has been deleted from this bottom water cell set. And again this set cell has been converted into the cell zone. Okay, so what I mean to say that, so first let me just run till here, then you will understand that. So first let me just run till here. So I will open here, I will run OF6 command, and let me just run block mesh, and let me run the topoSet. And if I run here paraform, this is the paraform. So if I include the sets, so difference between sets and zone, I think it is clear to you. So the only difference is that this sets, you can also use this sets for using the boundary condition or other post processing operation using the set. But speaking of, you want to create the different region like porous region or porous zones, then this zones should be preferred, and some commands like this split mesh regions, this only work on the cell zones. Another things that you can observe here, so when you open the polymesh folder of the constant, so you see here that this whatever the cell sets you will create, it will create it into the subdirectory of this polymesh. So whatever the cell sets you are creating here, that will be created into the subdirectory of this sets. Okay, but when speaking of the cell zones, it will be created into the same directory of the polymesh. So that is another difference that you can observe here between the cell zones and the cell set. But speaking of means whether using the bounded condition on the cell set or the cell zones, both can be approachable. But in general, when you are using or applying a standard boundary condition which are predefined in the open form SRC folder, or the different models like porous media models or turbulence model which has been already defined in the SRC folder of the open form, then this it is means it is in general it is required to convert the cell sets into the cell zones. Okay, so it should be preferred that first you convert this into the cell set, then this cell set should be converted into the cell zone. That should be preferred if you are applying any standard boundary condition or standard model present in the open form. And also otherwise you can use the cell set if you are defining your own boundary condition, or if you are doing another processing. So in such situation, this cell set can be also used here. And another difference that I told you, that this split mesh region type of command always works on the cell zones. Okay, So it should be preferred in a way, I can say that. And another difference that I told you, that this cell zones, when you convert cell sets into cell zones, this will be present in the polymorph directory, whereas the cell sets will be present into the this subdirectory of the polymorph. Now when I open here, and let me just include the sets here. I'm not including the zones. You can include the zones here from here also. And let me just show you that. So you have bottom water cell heater, left solid set, right side. So these things I have selected here. So let me just turn off this bottom water cell set. Okay. And also I need to first turn off all the meshes. And then I should turn on this. So this is the top here. This is the right solid. This is the left solid. And this is the heater. So this we have created using the right solid, left solid, and top here. Okay. Now if I turn on this bottom water cell set, you can see the same mesh you can find here. It is a similar to that whatever we have selected here, because the source info of this bottom water cell set is this header cell set, left solid cell set, right solid cell set. Now when we turn on here, so when we turn on this invert action, so it is going to select all those cells which are not being covered here. Okay, so these are the cells that has been selected till now for the bottom water cell set, but when we are going to invert it, it will just select all those cells which are not is part of the present scene, and again we will convert into the cell zone set using this command. So let me again run this. Okay, sorry, I need to save this. Okay, so now I have reselected it, and now I can show you again that how it is going to show you. So let me unselect all the meshings and I can include sets. Now if I turn on the bottom cell set, so you can see here that the cells which are not the part of the meshing earlier has been now selected here, and it will become the bottom water. Okay, so this is how this topoSet has been used. If I open these folders, you can see here that there is no any polymesh here. This right side is no different polymesh here. Bottom one there is no polymesh here. System also you can see here that there is a no any kind of information that is been given here. So in multi-region solver, there should be different polymesh for each region. Different polymesh for the each region. So when you run this split main sorry, this command split mesh region cell zone override. So when you run this command, it is going to read this cell zone folder, and there you can see that four different kind of cell zones has been found here. So it is going to write every folder. So it should be updated till now, because we have again, sorry, there should be 5 region, since we have again run the topoSet. So I think now it should be updated here. Okay, so you can see here that it has the 5 region: heater, and then you will go to, then you can find the left solid. Similarly, you can find the right solid. And similarly, you can find the top air, bottom air, and whatever the cell zones we have created. So this command is going to read the cell zones, and based on the information in the cell zone folder, it is going to create different polymesh into this folder and every folder. So let me run this command and let me show you. So here you can see that there is a region 1 and region 0 name is bottom water. So C++ works from the 0. So that is why this first numbering starts with the 0. So region 0 is bottom water, region 1 is the left solid. And once this command has been run, here you can see that this polymesh has been created for this folder. Similarly, this polymesh has been created for this folder, and this is also works on here. So that is why in such scenario, this converting all cell sets into the cell zones are very important. Okay, it is going to work on the cell zones only. So this is how this topoSetDict worked. So if you want to know more about topoSetDict, then you can visit this website, that is openfromwiki.net and topoSet, and here you can find a different thing. Okay, so dict file I have already show you that how this dict file has been used. This latest time, that if you are working on the latest time, so there is, if certain folder is given, like suppose here folder name as the 1 is present here. Okay, and suppose this two folders is not present earlier. Okay, so this is the simple mesh that we have created here. Now if we want to use this latest time command, if I run this latest time, so you can run this command, and even we go to this folder polymesh, you can see that there is a sets folder has been present here, that is containing the complete cell set things. Okay, now one thing you also observe that this is no cell zone has been created, even though we have run this command of the cell zone set, and you can see that here it is forming the sets to cell zone. But here you cannot find the cell zones, because as I told you that cell zone operates under standard library or standard things that has been provided by the OpenFOAM. So generally it is required that whatever the cell zones we are creating, that should be created before running the solver. So different cell zone cannot be created in a while running the solver, or while doing the simulation. So this cell set can be modified, or can be created, or can be deleted, or can be edited whenever you want, even though you are doing the simulation. But cell zones cannot be modified or cannot be created while you are doing the simulation. That is why on the latest time, these things that creating a different cell zones is not going to work. Other things, this you can run from the constant folder, and for different region you can run using this command. Okay, then visit these tutorials, you can find all kind of examples that is being required in these tutorials here. These things I have explained here. Okay, now I think it is clear to you. If you want to convert box to cell, then you can use this command. You can want to just convert cells to cell. So here you can see that we are converting cell to cell, cell to cell, and cell to cell. In such scenario, this set to cell command is useful. So I think you just read here, you want to create from a cylinder to cell, then this command is very useful. Okay, just read these things, these articles. Okay, now one thing I want to point to you that if you want to select a cells from a given box, before finishing this tutorial on topoSet, let me just make a clear point about the bounding box that you have to select. Okay, so here you can see that this tutorial I have taken from the understanding the meshing tutorial, And if I open the bounding box, so here you can see that we have created a simple cubic geometry. So this is geometry that we have created that time, and this is the meshing. So you can see here that there is a uh, means only 27 cells are there, and if I open the block mesh dict, okay, so yeah, you can see that the means length of this block mesh dict is in x direction, this is going to 0 to 1, y is also 0 to 1, and z is also 0 to 1, and we are creating only 3 meshes across each direction, so there will be 27 meshes. And if we divide the means if we take the length of the breadth of or the means you can say that side of a given cell is around 1 by 3, so that is around 0.33. This side is 0.33, uh, means you can say that meter, this the length is the of the given cell. So that is something like a mesh that we have created to understand that what I want to say, that we need to extend a little bit if you want to select some specific cells. Okay, so here you can see that I have taken 3 examples. Okay, so first we are suppose we want to only select a single cells. So we want to select only single cell in the center of the all the 27 cells. Okay, so this that center cells that we want to select. So of course you can figure it out that the center of this given cell is in x direction, it will be 0.5, in y also 0.5, and z also it is 0.5. So let's see that whether it is able to select that cell if we are specifying the specific the cell center. So if I put here 0.5, 0.5 and 0.5, so let's see that whether it is going to take that cell into consideration or not. So let me just zoom in little bit, and let it OF6 and block mesh. And if I type topoSet, you can say that it is only selecting 0 cells. Okay, why? Because if you want to select that cell, then in that scenario we have to extend a little bit. Okay, so the minimum vertices should also be extended, and the maximum vertices should also be extended a little bit, so that that cell lies within that given bounding box. Okay, so that center of that cell should be lie within a given bounding box, then it is going to only consider that cell. So what I mean to say that, so if you want to select that cell, so we should extend a little bit the min and max of the given bounding box. So if I open this, so here you can see that the center cell lies within here it is a 0.5. So either we can go to the in min direction we can take it as a 0.4 and little bit something beyond 0.5 for a max vertices direction. Okay, so this we cannot use if we want to use for that purpose. So we can from 0.5 we have to little bit go towards the mean, so that we can take as a 0.4, 0.4 and 0.4. Similarly in the max direction we can give this vertices as a 0.51, 0.5 and 0.51. So in such scenario, this center of this 0.5, 0.5 of a center cell, it is going to lie within this bounding box. Okay, so this is, I'm just giving an example for one single cell, but similar approach you have to follow if you are selecting a number of cells in a given bounding box. So if you want to consider completely bounding box within a given range, so what I mean to say that, so the suppose you want to select all the cells lies within 1, 2, 3, 4, 5, 6. So in such case, we have to specify little bit in the lower side. You have to specify like 0.99, 1.99 and something like 3 2.99. So it depends upon what is the cell size you are taking. So if suppose cell size is 0.01, then this 0.99, and suppose in similarly you can extend in the this max vertices side. So this can be around 4.01 and 5.01 and similarly 6.01. So this is how you can select all the cells lie within this 1 2 3 and 4 5 6. Now this we have taken to consider a single cell. Similarly we can run the topoSet now. We can run the topoSet and now you can see that we have selected one cell. And if we open the paraform, so we can just turn on this and include the sets, and here you can see that if I turn on this cell set, so only one cells of the centers has been selected. Okay, that all the cell centers lies within the given boundary box should be selected. So this approach you have to follow based on the cell size or the element numbers. Okay, so this whenever you are using this commands like this command and this command, it should be make sure that while you are selecting the radius max and minimum point of the central height of the cylinder, this point should be selected in such a way. Here these commands we have already uh, included. Here you can also specify that what kind of face set you want to select, either neighbor, owner, or any face you want to select, all the face you want to select. Here when you have different zones, then there you can use for selecting the all the zones related to a given face. This you can convert to filled into the cells. Okay, so like if you filled, okay, then whatever the min and max value will provide them. So suppose you have you want to select all the cells you which have velocity within the 0 to 5 meter per second. So here you can see right that field to cell, and the field you can specify u, and you can give the minimum value and maximum value. Okay, here again you should keep in mind that if you want to select the velocity between 0 to 5, it is better that just give a value that is little bit larger than 5 value. Okay, so you can give 5.001 kind of thing you can try here. Okay, here you can just specify a given level, and that level are going to select it. Suppose you want to select all the cells which has numbering between 0 to 10, so you can see use this command label to cell, and you can specify number equal to 0 1 and something like up to the 10 or 9. Okay, if you want to convert all the neighboring cells, okay, then this command can be used, that is going to select all the neighboring cells. This can be used to convert the nearest to cells. Okay, this is useful while you are using the dynamic mesh movement. This is for the multi-region kind of things. Okay, this is just to select the surface to cell or shape to cell command. Okay, so these things you can try here. So I think generally up to this is very useful if you want to use the topoSetDict. These commands are specific to some problems that you can use here. Okay, these are the something related to the specific problem. And similarly here this is the face set sources. So if you want to convert something into the face, then these things can be used here. And point sources, this is for the means dynamic mesh motion kind of things. So you can go here, and if you want to do a specific problem, then you can just refer to these tutorials. Okay, so because if I explain only topoSetDict, there are various possibilities. So you can set you can see these things, and you can I think if you do permutation and computation, you can see that how many test cases I have to show, which is not possible in this one tutorial. So here you can make permutation and computation, and you can create a lots of test case example. So just do, and if you have any confusion, or if you have a problem in using any kind of commands that is specified here, you can just ask me in my video comment section, and I will surely help you at any level. Okay, so I hope this tutorial is useful for you, and please subscribe my YouTube channel.